Hey everyone, welcome to homework 3.9. In today's lesson, we looked just a little bit more at these exponential functions in real world situations. So we're going to continue that in the homework. So the number of people with the flu during an epidemic is a function of f of the number of days d since the epidemic began. The equation f of d equals 50 times 3 over 2 to the power of d defines f. Okay, so it says how many people had the flu at the beginning of the epidemic. So that would be 50, right? That's our starting value. How quickly is the flu spreading? So this means that it is multiplying by 3 over 2, 3 halves rather, which is times 1.5. So times 1.5 each time, right? So every day it's spreading to additional 1.5 people. What does f of 1 mean in this situation? So this means after 1 day, the number of people with this type of flu. Does f of 3.5 make sense in this situation? So this would be saying 3.5. Remember, that's the days, that's the input. So could we count 3.5 days? Yes. We could say that at 3.5 days, how many people have since caught the flu? Because we can count partial days. All right, the function f gives the dollar value of a bond t years after the bond was purchased. The graph of f is shown. What is f of 0? So this is 1,000. And so that means that is the starting value of the bond. Sorry, the dog is crying. Of the bond. It says, what is f of 4.5? What does it mean in the situation? So this is at 4.5 years. The bond is worth, let's look, 4.5 would be between 4 and 5. That's right about here, right? That's about our point. And we're going up here by 1,100, 1,000, so by 100s. And so this point in between 1,200 and 1,300 is probably about 1,250. It says, when is f of t equal to 1,500? What does this mean in this situation? So f of t is equal to 1,500 a little bit between 8 and 9 years. So between 8 and 9 years, shortly after the beginning of the 8th year probably. And this means that the bond is worth $1,500. A function f gives the number of stray cats in a town since the town started an animal control program. This program includes both sterilizing stray cats and finding homes to adopt them. An equation representing f, so the number of stray cats, is 243 times 1/3 to the power of t. What is the value of f of t when t is 0? So at the start, that would be 243. Oops. And that is the starting amount when number of cats were first counted. All right, what is the approximate value of f of t when t is 1/2? Explain what this value means in this situation. So if we were to put f of 1/2 equals 243 to the power of 1/2, right? Thinking about what you would get here. So if you use your calculator to calculate that, this is first of all saying that that 1/2 is time, so that's half a year, right? So at half a year, how many cats do we have left? Oh, and actually, I'm sorry. This should be 1/3 to the power of 1/2. So my bad about that. So we have 1/3 to the power of 1/2, which is 0.577 times 243, which gives us 140. So after half a year, we now have 140 cats. This makes sense because we are decreasing the amount to 1/3 or by 2/3, and so what's left is 1/3. And so at half a year, it would be more than 1/3 of the cats. What does the number 1/3 tell you about the stray pop? Oh, I just said that. So this is the ratio of cats left in the population. So approximately 33.33% are left after a year. It says use technology to graph F for values of t between 0 and 4. What graphing window allows you to see the values? All right. So let me first of all go ahead and put this into my graph. I would strongly suggest you put this into Calculate 84. You could use Desmos if you wanted, or into your TI-84 if you have it with you. That would be ideal so that you can practice graphing this in your calculator. So we're looking at 243 times 1/3 to the power of x. And then graphing that. And it wants me to graph it between 0 and 4 for values of t. So where x is between 0 and 4. So I have that in my window. So you go to Window and change your x min to 0, your x max to 5. And then the starting value of my cats is 243. So for my y max, I'm going to go ahead and do 250. And my y min is going to be 0. And so when you do that, you can see the starting amount of the cats and how that is decreasing. Oops, I went the wrong way. Decreasing over time. And so you can draw a little sketch of this in which we have 0 to 5, right? 1, 2, 3, 4, 5. And then we're going up to, I have it at 250. Starting value is 243, so a little bit below that, and then it's slowly, or rather quickly, decreasing and getting closer and closer to 0. So the graphing window is where x is less than 5 and greater than 0. That's our x-axis here. And then y is less than 250 and greater than 0. Function G gives the amount of chemical in a person's body in milligrams t hours since the patient took the drug. So this is quite commonly an example of medicine decaying over time or dissipating over time. So you have 600 times 3/5 to the power of t. What does the fraction 3/5 mean in this situation? So this is 3/5 is left in the system each hour. And we could also say 60%, right? So 60% is left, or 3/5, or 0.6. Sketch a graph of G. So again, we're starting up here at 600, and then we're thinking about over time how quickly this is going to dissipate. So again, you can use your graphing technology to kind of get an idea of what this is going to look like. And I'll show you. And I'm going to set my window to be, this time my y max is going to be 600, because that's the starting amount of my medication that I'm taking. And then over time it is decreasing. And again, I have it set from 0 to 5 because we're thinking 5 hours. I'm going to change it 0 to 8. I mean, maximum, right, we would think it's that amount of medicine will be there about 8 hours, right? And so again, we have a curve that is decreasing and going towards and approaching 0 over time. All right, and again, this is a sketch, so it doesn't have to be exact or perfect. And then domain and the range. All right, so the range is y is the range, so y is greater than 0 and less than 600. Less than or equal to 600, because at one point it is 600. And then the input, or the time, right, our range is ranging from, now this I would say ranging from 0 to, now I have it at 8 hours here. Let me see where it is at 8 hours. So at 8 hours, scooting along. So when we get to when we get to 6 hours, we're looking at 17 milligrams, 7 hours, 8 hours. So at 8 hours, we're at 8, I believe it's milligrams. Let's see. Yes, we're at 8 milligrams. And as we continue on past 8, we're getting smaller and smaller and smaller. And when it starts to get into decimal land, we're looking at about probably 12 to 13 hours. All right, so when it's at 0.84 milligrams, it's pretty small. So I would say ranging from 0 to 12 milligrams max, right? And that's generally where we would be looking at it, because when it gets to that point something milligrams, it's a pretty small amount. But it's going to continue to get closer to 0 and not quite there. The dollar value of a moped is a function of time years since the moped was purchased. The function f is defined by this equation. What is the best choice of domain for the function f? All right. So we are starting at purchasing this moped at this amount. In this case, we're probably not going to be talking about time before the year of purchase, because things tend to go down after we purchase them. So we generally wouldn't be looking at time before the purchase of the moped, unless maybe it was a used moped. But instead, I would say the domain is probably best between 0 to 10 years. 0 to 100 years is 100 years. To have a moped for 100 years is pretty unrealistic. So between 0 and 10 years makes the most sense to look at that value over time. Again, you could look at it all the way to 100 years, but that value at that point is going to be so little, it's not really worth it. Okay, a patient receives 1,000 milligrams of medication, so we can go ahead and put that there. Each hour, 1/5 of the medicine in the patient's body decays. That means that 4/5 remains, so that then is going to be our factor, right? So each time I'm multiplying by 4/5, or this is also equal to 0.8, 80%. So 1,000 times 0.8 is going to give you 800. Then I'm going to multiply that times 0.8, and I will get 640 times 0.8 is 512, and then times 0.8 is 409.6. All right. It says write an equation representing the number of milligrams medicine in the patient's body each hours. So m equals, I believe we started with 1,000 times 4/5 to the power of each hours. And again, that 4/5 is the factor that we're multiplying by each time, because 1/5 decays, and the factor is how much remains. All right, use your equation to find m when h equals 10. So m equals 1,000 times 4/5 to the power of 10. And so in this case, our medicine is decaying over time. So we're going to do 1,000, oops, I just did something weird, 1,000 times, I'm so sorry that the dog is so loud right now, to the power of 10, which is going to be 107.37 milligrams left after 10 hours. And because this medicine was decaying at a very slow rate, all right, only 1/5 each hour, and it started at 1,000 milligrams. That makes sense, and it's going to take a little while to get out of the body. All right, number 7, the trees in a forest are suffering from a disease. This is the population of trees. So if they're suffering from a disease, we have decay, right? The number of trees is going down, and it's since the year 2000. So it says, what was the population in 2001? So in this case, we're going forwards 1 year, so 90 times 3/4. Or 75% of 90. which is 67.5 in 2001. But the year before then, we would be looking at 90 times 3 over 4. Oops. I know, she sounds so terrible. She really just wants me to take her upstairs right now. I'm about to do it in a second. To the negative first power. So 90 times 0.75 to the power of negative 1 will give us 120. And that makes sense, right? Because before this, there would have been more trees. And so if you want to, you can also work backwards and say 90 divided by 0.75, and that will also give you 120. So this is 2001, and this is 1999. All right. 3/4 tells us how the ratio of trees left. In this case, 75% of trees remain each year. It says, when was the last year the population was more than 250,000? Explain how you know. All right, so 250,000 would have been before the year 2000. And so we'll set up our equation this way, and let's go ahead and divide by 90. And so we'll get 3/4 to the power of t equals 250,000 divided by 90. And that was 2,777.7, we'll round to 78. So we want to figure out what number we're multiplying, or what number we're using in the exponent to make it this number. So you're going to try numbers. So 0.75 to the power of, now remember we're going back in time, so I'm going to try negative numbers. We know that negative 1 got us 120. We're going to need to go much further back in time. So I'm going to just shoot for negative 10 and see what I get. If I put 0.75 to the power of negative 10, I only get 17.75. So even further back in time. So I'm going to do 0.75 to the power of negative 20. Let's see if we get closer then. Now I have 315, so we're getting closer. Let's try 0.75 to the power of, let's try negative 30. We'll go up by 10s here. Oh, okay, so now when I do to the negative 30th power, I have 5,500, or 5,599, to be more exact. So I need to make that a little bit smaller. So 0.75 to the power of negative 25. Let's try that. And now I get 1328, so 0.75 to the power of negative 27. Let's try that. And now I get 2,362. So 0.75 to the power of negative 28 gives me 3149. So it's somewhere between 27 and 28 years ago. So between 27 and 28 years before 2000. So we're talking about between 1972 and 1973, right? So somewhere in that range. And again, once you get this, you're simply plugging in numbers for t to try to get as close to this number as you can to help you figure that out. All right, number 8. All the students in a classroom list their birthdays. Is birth date B a function of the student S? So this means for every input of students, do we have one birth date output? So yes, because each student only has one birth date. Is the student S a function of the birth date B? So this could or could not be a function, because it's likely not a function because there's probably more than one person for each birth date. So for each birth date, there could be more than one person. And so remember, the function of this is the input. It's saying if we have the input of the birth date, the output would be the student. right? And so there could be more than one student with that same birth date. Here, it's a function of the student. So the input is the student, the output is a birthday. We only get one birthday per student. Number 9, Mai wants to graph the solution to the inequality on a number line. She solves the equation and gets -5 for x, which graph shows the solution to the inequality. So here we are looking at, if we were to do this, she would get 3x is greater than, and she adds 4 to both sides, -15. X is greater than -5. And so our best equation then would be A, our best graph here, because we're looking at -5, open circle, and moving to the right, greater than -5. All right, so here you have some review problems, and these are modeling some types of problems you could see on the park, and just going over some review so we don't forget some things. So this first one is asking which statement must be true. The water to the right shows depth of water in the sink in inches and can be modeled by this function. Which statement is true? So the water was at its lowest before 1032. So this is at 1032, and the water is pretty low here. However, it is also that same amount of lowness in this last 7 to 8 minute mark. So while it is true that it is low before 1032, it's not the lowest because there's 2 places that it is at 0. There is 0 inches of water in the sink at 1030. Well, at 1030, we do have a point at 0, so that is true. The water increased the most from 1032 to 1033. So from 1032 to 1033, that's our slope. That's a pretty flat slope. It's not super steep. It's much steeper in this range right here. And so that is not true. It is not increasing the most then. And then letter D says a total of 2 inches water were poured into the sink from 1030 to 1038. So between this amount of time, it says a total of 2 inches were poured into that. You might be tempted to say that because that is the tallest point here. However, we do not know if the water was draining at the same time. So if the sink was also draining and more water was being poured in, it could be that more than 2 inches were actually poured in. We do know that 2 inches was the maximum depth of the water, but we don't know how much water was actually poured in. So this is kind of like the tricky one that they might throw in there to throw you off. All right, this last one is reviewing functions. And so if x is the domain or the input and y is the range or the output, is it a function or not? So if I were to put in any number for x, 1, 2, 3, 4, 5, -1, I will get exactly one output, right? If I put in 2, then y equals 2. If I put in 3, then y equals 3. This one is a little bit tricky. If I put in 1 here for x, what are my possible outputs for this y? Well, this could be that y is -1, or it could be that y is +1, because if I put -1 into the absolute value bracket, I will get a +1 in return. If I put 1 in here as a positive y value, I will get 1 as an output. And so because there are 2 potential outcomes to this, this is not a function. This next one, any number that I put in here is going to give me a different number. If I put in 1, there's not 2 possible answers. We'll get 3. All right. Here, if I put in 1, I get an output of 1. If I put in -2, I get an output of +2. I only get one output for each input that I put in there, so this is a function. Remember, absolute value functions look kind of like this. This absolute value function would look like this, right? And so it does not pass the vertical line test there. This one here, similarly, if I put 4 in here for x, I would get both a positive and a -2, which means that this is not a function because I have 2 outputs for every possible input. And then lastly, if I put any number in here, I put 2, 3, 4, I will get 1 value for that as a possible answer. So as long as your input only has 1 possible output, it is a function. If your input goes in there and it has 2 possible numbers that could be as a result, then it is not a function. All right. Your code word for today is ruler. Write that at the top of your paper. Happy homeworking, and I'll see you tomorrow.